Azure Key Vault is a powerful service that allows organizations to securely store and manage cryptographic keys, secrets, and certificates. To ensure the utmost security, it's essential to configure the appropriate network settings for Azure Key Vault. In this training module, we're going to explore how to configure Azure Key Vault networking settings to control access and secure the communication between the Key Vault and other Azure resources. By the end of this training, you're going to be able to understand the importance of configuring network settings for Azure Key Vault in ensuring secure access and communications. You'll learn how to configure network access controls to Azure Key Vault using the virtual network service endpoints and private endpoints. You'll gain insights into configuring firewall rules and virtual network service endpoints to restrict access to Key Vault. You'll understand the process of configuring private endpoints to securely access Key Vault from virtual networks. You'll recognize the benefits of properly configuring network settings for Azure Key Vault, enhancing overall security. So let's get into this. Azure Key Vault is an Azure service designed for securely storing and accessing secrets such as API keys, passwords, certificates, and cryptographic keys. It supports two types of containers, vaults and managed hardware security module pools, or HSMs. Vaults can store software and HSM-backed keys, secrets, certificates, while managed HSM pools only support HSM-backed keys. Key Vault requires authentication to perform any operations. The methods include managed identities, service principals, certificates, and secrets, with managed identities being the recommended method. Key Vault enforces TLS, or transport layer security, to protect data traveling between Key Vault and clients. TLS provides strong authentication, message privacy, and integrity. Perfect Forward Security, or PFS, is also supported to protect connections by using unique keys for each session. By default, when you create a new Key Vault, the firewall is disabled, allowing all applications and Azure services to access it. However, operations on the Key Vault still require authentication and access policy permissions. I'll be doing an example of that in just a few minutes. Key Vault uses Azure Role-Based Access Control, or RBAC, for managing access, and key roles include owner, which has full control of the vault, contributor that can manage the vault but cannot change access roles, and reader that can view vaults and their contents. There's also specific ones for Key Vault of managed HSM's administrators that have the complete control over the managed HSM pool, managed HSM crypto officer users that can perform cryptographic operations using keys in the managed HSM. So I want to go to a whiteboard and just describe what some of these things are. So let's go to the whiteboard and I'll hopefully graphically show you what it is that we just talked about. So if you take a look at a Key Vault as an Azure resource, it is protected by RBAC. And so the role-based access control, as with everything in Azure, protects the resource itself. And this is where we talked about some of the roles that you have. Inside of the vault, you're going to be able to store certificates, secrets, passwords, any of that other information. So now, to manage the vault itself, there's a thing called separation of control or separation of concern. We talked about the three different roles of owner, contributor, and reader. You typically want three different individuals from a security perspective to manage these three different roles. A person is going to be responsible for the configuration and the creation of the vault itself, and configuring the permissions to be able to manage the vault on an ongoing basis. This might be your security analyst, while the person creating the vault might be the infrastructure manager. So the infrastructure people create the vault. They then will turn that vault management over to, say, a security officer that will be responsible for publishing the certificates and the keys and the secure information into the vault itself. And then they will be able to manage which users or applications will be able to come in and consume those resources or read those values. Inside the vault, Access to the vault can happen several ways. It can be accessed through a thing called a policy, which exists inside the vault. And so a user or application would need to have reader permission to access the vault, and then that vault access, once granted, a policy inside the vault will control access to the information inside of the vault. Another way that can happen is, whether it be an application or a user, they can access the vault using an RBAC permission, the role-based access control, using Enter ID or your identity management services to authenticate the user and then grant that user or application, hopefully a managed identity, to gain access to the certificate. So that's what we were just talking about, is the creation of the vault and the RBAC permissions for the management. Following the recommended best practices, we've separated those three different roles out to who can manage the vault, who can create and change permissions on the vault, and who can consume things from the vault itself, and then the configuration of the information in the vault and the different ways to access it. So let's go back to the content. In summary, Azure Key Vault is a secure cloud service for storing and accessing secrets with robust authentication and encryption mechanisms. Microsoft recommends using separate key vaults for different applications and environments, controlling access through RBAC and least privilege policies to enabling logging and purging protection for enhanced security. I'll get more into this as we go into it about the different types of vaults. It is recommended to use a separate vault for each application, environment, development, pre-prod, and production, as well as region. This practice prevents secrets shared across multiple environments and reduces the impact of a breach. The cost of Key Vault is not based on the number of vaults, but the use of a vault. So having 5 people use a single vault across 5 different environments has no difference to the impact of cost of a person who has 5 different vaults, each containing one set of that information. So that's what I was trying to say there is, Microsoft's recommendation is to have multiple vaults. Grouping secrets into the same vault increases the blast radius of a breach or security event. Separating key vaults by application or service group mitigates access across your concerns. Secure key vaults by restricting access through role-based access control, or the RBAC, with those least privilege access policies, firewalls, and data protection features. And that's what I was describing in my whiteboarding session. You'll need to create access policies for each vault and use the principles of least privilege to grant access. You're going to want to turn on firewall and virtual networking service endpoints to restrict access to specific IP addresses and virtual networks. And we're going to be covering more of that in this rest of this module and the next module. You're going to enable purge protection along with soft delete to guard against malicious or accidental deletion of the secrets and key vaults. Soft delete is enabled by default, allowing recovery of deleted vaults and objects for a configurable period of 7 to 90 days, with 90 days being the default. Turn on logging for your vault and set up alerts to monitor access and changes. Logging and alerts help in auditing and responding to security incidents. Purge protection prevents permanent deletion until the retention period ends, ensuring data recovery. Azure Key Vault is designed to securely store and manage sensitive information such as your cryptographic keys, the certificates, secrets, the API keys, and passwords. To maximize security, it is crucial to control network access to the vaults. You can enhance security by specifying which IP addresses and virtual networks can access your key vaults. Azure Key Vault supports virtual networking service endpoints, allowing you to restrict access to specific virtual networks and IPv4 address ranges. Any user or service attempting to contact the vault from outside these specific sources will be denied access. Azure Private Link Service enables secure private access to Azure Key Vault and other Azure services over a private endpoint within your virtual network. This private endpoint uses a private IP address from your virtual network, effectively bringing the service into your network and eliminating exposure to public internet endpoints. Azure Key Vault enforces the use of TLS to protect data in transport between the clients and the Key Vault itself. TLS provides strong authentication, message privacy, and integrity. The HTTPS protocol allows clients to participate in TLS negotiation, ensuring secure communications. When you create a Key Vault, it is automatically associated with the Microsoft Entra directory of the subscription used to create the Key Vault. All users must authenticate to access the Key Vault using that Entra directory. Authentication methods include managed identities, Azure resources, service principals, certificates, service principals, and secrets. Managed identities are the recommended method as they simplify credential management and rotation. Microsoft recommends using virtual network service endpoints to restrict access to your Key Vault from specific virtual networks and IP address ranges. For enhanced security, use Azure Private Link to access Azure Key Vault and other Azure services over the private endpoint. Ensure all communications with Azure Key Vault use the TLS and HTTPS protocols to protect data in transit. So before I go to the actual demonstration, in a summary, the Key Vault network security involves restricting access to IP addresses and virtual networks using private link or secure connections, and enforcing TLS and HTTPS to secure communication. We recommend using these features to enhance the security of your Key Vaults and the data stored within them. So let me go to a whiteboard and show you some of what it is we just talked about. So what I've got here is a sample of what it is that we were just talking about. Previously, we talked about the vault itself, and you would need the permissions to create the vault, then to pass off to the RBAC permission for someone to manage the vault, and then someone to be able to read the vault. Now, that vault exists within a network segment. You can see the bottom portion of that line that I've drawn here that indicates the IP address of the vault. And as you would do in regular networking, the resources on that same subnet would be able to access the vault. I can put, firewalls and RBAC permissions around to lock this down, but by default, how am I going to allow this communication? Well, I may not want to open up, to all users or other applications in other networks to be able to gain access to my network, to gain access to my vault. And so some of the concepts that we've talked about, and these are covered in other networking courses, but what we were talking about is you can create a thing called a private endpoint. And so while the IP address within Azure for the Key Vault might be something, what I want to do is to create what appears to be an instance of the vault itself and place it so it appears to be in the network that is going to consume the vault itself. And so it ends up creating a network card with an IP address on the subnet that the user or application that needs to access the vault. And it thinks it's accessing it locally, but it's actually going to go through a secure TLS or HTTPS connection through that network, secure communication. No other parts happen. We don't have to open up the entire networks. And so I've done is actually made what appears to be a pseudo instance of that vault accessed by a local network service that you're dealing with. So that's what they're talking about, that private endpoint capability. Now, other services, and we're going to cover more of this in the next module. We're going to get into this concept a bit deeper when we talk about secure access to things like SQL Server and how it uses private endpoints, private link, and service access points to be able to gain access to these. But that's exactly what it is that we were talking about. By default, when you create a new Key Vault, the Azure Key Vault firewall is disabled. All applications and Azure services can access the Key Vault and send requests to the Key Vault itself. This configuration doesn't mean that any user is able to perform operations on the vault. The Key Vault still restricts access to secrets, keys, certificates that are stored inside of it, either by requiring an authentication or through an access policy. When you enable the Key Vault firewall, you are given an option to allow trusted Microsoft services to bypass this firewall. The trusted services list does not cover every single Azure service. For example, Azure DevOps isn't on the trusted list. This doesn't imply that the services that do not appear on the trusted services list aren't trusted or are insecure. It is just that the list of services where Microsoft controls all of the code that runs in the service has been trusted. Since users can write custom code in Azure services such as Azure DevOps, Microsoft does not provide the option to create a blanket approval for that service. Furthermore, just because a service appears on the trusted service list doesn't mean that it should be allowed for all scenarios. If you'd like to authorize a particular service to access Key Vault through the Key Vault firewall, you can add its IP address to the Key Vault firewall allow list. This configuration is best for services that use static IP addresses or well-known ranges. Note that there is a limit of 1,000 CIDR ranges in this case if you're going to use that. If you're trying to allow an Azure resource, such as a virtual machine, through to Key Vault, you may not be able to use a static address. And you may not want to allow all the IP addresses of an Azure virtual machine to access the Key Vault. In this case, you should create the resource within a virtual network and then allow traffic from the specific virtual network and subnet to access the Key Vault. And that's going to use that capability that I described in my whiteboarding. It's important to note that after firewall rules are in effect, users can only perform Key Vault data plan operations when their request originates from the allowed virtual networks or Internet Protocol IPv4 address ranges. It also applies to accessing Key Vault from the Azure portal. Although users can browse to the Key Vault from the Azure portal, they might not be able to actually get a list of the keys, secrets, and certificates if their client machine is not on the allow list. This also affects the Key Vault picker used by other Azure services. Users might be able to see and list the vaults, but they will not have a list of the resources inside of them, preventing their client machines accessing their resources. There's also some configuration limitations. A maximum of 200 virtual network rules and 1,000 IPv4 rules are allowed. IP networking rules are only allowed for public IP addresses. IP address ranges reserved or private networks that aren't allowed in the IP rules. Only IPv4 addresses are supported at this time, so no IPv6. To enhance network security, you can configure your vault to disable public access. This denies all public configurations and allows only connections through private endpoints. Azure Key Vault's soft delete feature allows for the recovery of deleted vaults and Key Vault objects, such as keys, secrets, and certificates. When an object is deleted, it remains recoverable for a configurable period from the 7 to 90 days, with the 90 days being the default. This feature provides a safety net against accidental or malicious deletion. Purge protection is an optional feature that prevents the permanent deletion of the Key Vault objects until the retention period ends. This feature adds an additional layer of security by requiring elevated permissions to purge a soft deleted object. Purge protection is recommended for scenarios where the data loss prevention is going to be critical. To recover a soft deleted object, specific permissions are going to need to be required. The recovery process involves listing the deleted object and issuing a recovery command. It's important to note that recovery of a soft deleted Key Vault does not restore integrated services such as Azure RBAC role assignments and Event Grid subscriptions, which will need to be recreated manually. Actions related to purging and recovering Key Vault objects are billed as normal Key Vault operations. For HSM-protected keys, charges apply if a key version has been used in the last 30 days. Additionally, soft delete affects application logic, as names of deleted vaults and objects cannot be reused until they are purged from the soft delete state. So soft delete addresses scenarios where accidental or intentional deletions occur. It ensures that deleted objects are retained for a specific period of time, allowing for recovery. The retention policy interval can only be configured during Key Vault creation and cannot be changed afterwards. I also want to emphasize that during the retention period, the name of the soft deleted objects cannot be reused. Purge protection can only be enabled once soft delete is enabled. It ensures that objects in the deleted state cannot be purged until the retention period has passed. And again, we've stated this several times, it's in that configurable period between 7 and 90 days, with 90 days being the default. Key Vault recovery is when a key vault is deleted and a proxy resource is created under the subscription containing metadata for that recovery. This proxy resource allows for the recovery of the key vault and its objects during the retention period. I want to note that applications and administrators need to account for a soft delete in their logic and processes. This includes handling name conflicts and ensuring that security principals have the necessary permissions to manage soft delete objects. Virtual networking service endpoints for Azure Key Vault allow you to restrict access to your Key Vault to specific virtual networks. This enhances security by ensuring that only resources within your designated virtual networks can access the Key Vault, effectively isolating them from the public internet. Enhanced security by using these service endpoints will limit access to your Key Vault to the specified virtual networks, reducing and exposing potential threats. You can configure network rules to specify which virtual networks and subnets are allowed to access the Key Vault. And service endpoints integrate seamlessly with Azure networking infrastructure, making it easier to manage and secure your resources. For sensitive data, always enable service endpoints to restrict access to your Key Vault, and periodically review and update the networking rules to ensure they align with your security policies and organizational changes. And don't forget the typical security best practice of a layered approach by using service endpoints in conjunction with other security features like Azure Private Link and firewall rules and a multi-layered security approach. Imagine you have a web application hosted on Azure that needs access to secrets stored in Key Vault. By enabling virtual network service endpoints, you can ensure that the only virtual network hosting the web application can access the Key Vault. This setup prevents unauthorized access from other networks or the public internet, thereby enhancing the security of your sensitive data. Now we're going to go off to the exercise and actually implement a Key Vault. So we're back in the portal. I want to create a Key Vault. And as we've done before with other objects, I'm going to create it in the resource group using my subscription. I need to give it a unique name. I want to change it to US West. Because remember, Key Vaults are region specific. And we have different pricing tiers, and HSM, or the hardware security modules, typically only going to be used for production environments if you need that extra level of chip-based encryption on the device itself. I'm not going to change any of these other features. We'll get back into networking in just a few minutes, but I'm going to go into Review and Create. Create. Okay, it took a few minutes, but we've now got the resource built. So we're going to go to the resource, and we're going to go into the Key Vault, and we want to actually manage some of the networking services. We're going to come to Settings. We're going to get to Networking. And so we've got firewall rules, and here's those private endpoints, the two things that we talked about. So I can allow public, and we talked about that. By default, this is going to be enabled. I'm going to go into allow only public. And so now what I have is I've got virtual networks. If you remember in other previous modules, I can select from a set of existing virtual networks, or I can build a specific one. So if I go to the ones that I've already picked, I can see that if you remember back on the first module, I had VNet 1, and inside of your VNets, you actually had subnets that you can give access to. So let me select that VNet. And here's the subnets. Remember we had, there's the management virtual network. And enable that. It's going to take a minute to go through and build those firewall rules. I'll go through and add that. And apply. Okay, so we're back into the properties feature of the Vault itself. Now this time we want to take a look at the soft delete features. So under settings, down the left-hand side, under properties, you can see that I've disabled purge protection. So I'm going to enable that capability. Remember, once it's enabled, you can actually disable this. I'm going to save that feature. The soft delete is there by default, and so this is going to enable the purge protection capabilities. Save that. And I've now got that enabled on my Vault. So we've taken a look at Key Vault as a way to securely store secure information within your organization, and it truly is the best way to take information that used to be put into code or into control files that your application might use. So I strongly recommend that you use this, as well as all in relationship to Microsoft Defender for Cloud. These are all configurable values that you can put into your compliance controls to make sure that whatever the settings that you've got on your vaults are going to be held in compliance. And if they fall outside of them, do you want purge protection enabled? Do you want the soft delete capabilities? Do you have firewall rules enabled on them? And I'll do this in one of the other modules, is I'll go back and compare them to the configuration values of Windows Defender for Cloud to make sure that you are checking for that compliance. So thanks for participating in this lesson. I look forward to seeing you at the next module.